Thank you. It's recording. Oh, what is it? It's here. Ah,
1718. Okay. Okay. Can I lean on this weekend to help me with the R stuff? I'll do my best. Yeah. I mean, I also find that he's also taking 330, which I didn't even know when he's a computer science major. So maybe I was gonna take some help too. I wish I took his class. Although I don't know, he probably likes it more of the regular class because he says he gets some stuff done, like the a lot of class times online.
So, hello everyone. Can you all hear me? Loud and clear? Okay. So, where is the chat? Hey, it's here. So, how many do we have in the chat?
15 participants only.
15? Okay. So, I believe everybody saw the announcement that our classroom has changed. So, the exam is going to be on 406 Macquarie Hall, okay, MH, mathematics building.
You said 506?
406 MH 406. Yeah, it's in the chat. Yeah. MH. All classes are here now, okay? The only exam that might not be here is the final, but I'm going to check and I'm going to change so they can change the system. Okay. Let's do some exercise. So let's do joint and conditional probabilities, 3.13. Let me open the book. Those are my Brazilian taxes. You don't want to see my Brazilian taxes. Huh?
In Zoom, receive untitled notebook.
Untitled notebook. Ah, yep. So I need to share. I need to share it here. Okay. I cannot share it there. That's bad. Just a second, guys. So you can also open the book, exercise 3.13. So I will also open it here. Fine. So 3.13, think about it, 2 minutes, and let's do it together. Okay, so first thing in this question, we have some information here that it's in the general section, okay? So it means that this information will remain true through all the exercise, okay? So this is given. Good. So based on only this, P of A and P of B, can you compute P of A and B? What is missing here? Let me see in the chat. So you can compute it because we don't know whether A or B are independent or joint. Yeah, exactly. Yep. How are they related? Yep, exactly. So where is my, yeah, so you can see my, yeah. So we only know, okay? So we don't know if they are independent, okay? So we cannot, okay? But now, if you look to letter B, right? So what letter B is telling us is that assume that they are independent. So now we know that they are independent, okay? So knowing that they are independent, so this is letter A. Now we have letter B. So how can we compute this? How can we compute this? 0? Why 0?
Because of the.
Yep. Oh, uh, if they are independent, it uh they don't have intersection. No, no, yeah, no, this is a misconception. So if they cannot happen at the same time, it means that they are disjoint. Here, they are not telling us that they are disjoint. Okay? So not necessarily independent events are disjoint. Okay? Not necessarily independent events are disjoint. Okay? So P of A and B, if A and B are independent, you can split, okay, probabilities. So this is 0.7 times 0.3, or is it the other way around? It's the other way around. Yeah, it doesn't matter, but I just want to confuse people because this is P of A and this is P of B, right? So meaning that this is 0.21. Okay, so now C. Oh, it's not C, right? It's the part 2 of B. Part 2 of B asks you to compute the OR, right? And for this, we have a formula, right? So it's the union of two events. And since these two events are not disjoint, so we need to remove the intersection, right? And this is Oops, this is 0.3. This is 0.7. This is 0.21 that we just compute. So this is 0.79. Okay. Yeah, do you see? Yeah, because we have P of A and B. So now for the third part, what they ask is this. Probability of A conditioning in B. So what is this probability? Not necessary. It's just the definition of the condition probability. So what is the definition of condition probability? And what do you know about the condition probability if you know that the two events are independent? No matter what happens with B, right? It won't change A, right? If they are independent. So if they are independent, so since they are independent, B happens or not, does not impact the occurrence, pardon my English, occurrence of A, meaning that P of A given B is simply P of A, and this is 0.3. Okay, why is that? Remember, so what is the formula, right? The formula is P of A and P of B divided by P of B. But since A and B are independent, this symbol here means independent, you can factorize this, right? So you can chop this. Okay? So this symbol here symbol is with symbol. I don't know how to write symbol. It's the independence symbol. Is it correct, the spelling?
Oh, symbol. Yeah.
Symbol, symbol.
Here in single.
Single, oh, symbol.
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 Like Simba?
Like Simba?
Simba, Lion
The
King.
Lion King? Yeah,
Yes,
Simba. Symbol. Okay, symbol. Is it clear? Do we have questions in the chat? No questions in the chat?
What happened if they're dependent?
If they are dependent, then you use this formula. Okay? You use the formula. You find this. Probably this one is given, and then you divided one by the other. Okay? Can you use the formula for both? Yep, you can use the formula. Yep. If you use the formula, we know that we computed, right? That P of A and B is 0.21. And we know that P of B is 0.3, right? So this is 0.7. Oh, this is 0.3, right? It's because P of B is 0.7. So this is 0.3. So now we have another question here. Where is it? It's here. So if we were given that P of A and B is 0, 1, are the random variables given rise to events A and B independent? So now you forget everything that you got here. So now you forgot. So now we are not considering that they are independent anymore. So now we were giving this new information here. And based on this new information and in this information that we have here, they want to know if A and B are independent, okay? So to check if they are independent, we need to check this, right? We need to check if this is true, but the exercise told us that this is 0, 1. And we know from the general statement of the exercise that this is 0, 21. So these two guys are different, right? So PA and B in this case is different than P of A times P of B. So what is the implication here? A and B are dependent, okay? So far, so good? So, agora is now in Portuguese. So now, if we're given that P of A and B is 0, 0.1, what is P of A given B, right? So now it's just use the formula. So this one is letter C, this one is letter D. So we know the formula. So this is given 0, 0.1. This is 0, 0.7, meaning that if you divide 0, 0.1 by 0, 0.7, you got 0, 0.143. So it's just apply the formula. Okay? Good. Questions so far? So now let's do, let me see here my 3.15. So have a look at it, read it, and then let's do it together. So we have this research pool, and it asked 1,306 Americans. From what you've read and heard, is there solid evidence that the average temperature on Earth has been getting warmer over the past few decades or not? The table below shows the distribution of responses by party and ideology, where the counts have been replaced with relative frequencies, okay? So we have two variables here. What are the variables? Yeah, the variables are the responses, right? The response is a categorical variable with 3 levels. Earth is warming, not warming, don't know or refuse. And then the other variable that we have is the party and ideology. This has 4 levels. And this one is also a category, right? We have conservative Republicans, moderated or liberal Republicans, moderated or conservative Democrats, and liberal Democrats, okay? Now, A is asking us, are believing that the Earth is warming and being a liberal Democrat mutually exclusive? Yes or no? Answers in the chat. No, right? So why no? Because we need to look to these two levels here. Earth is warming, is this one. So Earth is warming. And then we need to look liberal Democrats. And then we need to check the intersection. So the intersection is different than 0. So we have people here, meaning that they are not mutually exclusive, right? So now for B, what is the probability that a randomly chosen respondent believes the Earth is warming or is a liberal Democrat? So what we want to ask here is probability warming or being a liberal Democrat. Okay, so this is an or. So if this is an or, this is probability of warming plus probability of being a liberal Democrat minus the probability of warming and being a liberal Democrat, right? Because we just saw on item A that this has an intersection. So now probability of warming is, what is the probability of warming? I just want the probability that the Earth is warming. 0.6, right? We just need to look to the column of warming. So you need to look here and you need to look to the total. That's the probability of warming. And what is the probability of being a liberal Democrat? Well, it's this, right? You need to look to the total of this one, okay? So what we need to do is 0.6 plus 0.20 minus the 0.18, okay? So this is 0.6 plus 0.20 minus 0.18 is 0.62. So for letter C, what they want to know is the probability that the Earth is warming given that the person is liberal Democrat. So we want a conditional probability. So is Earth is warming and given that the person is a liberal Democrat. Okay, so let's check our table. So I'm going to erase things here. So remember that I told you once, some weeks ago, that when we are conditioning, we are restricting our sample space, okay? You're putting like a constraint, right? So in this case, now we are constraining our data to the world of the liberal Democrats. So some are going to love to live in a world of liberal Democrats, others are going to hate. That is politics. So now we are in this world of liberal Democrats, right? And among these people, we need to check how many of them believe that the Earth is warming, meaning that we need to get this number here and divide it by this number, okay? So what we have is the 0.18 divided by the 0.20. And this is 0.9. Okay, so if you were to write in formulas, this is the probability of warming and the probability of being a liberal Democrat divided by the probability of being a liberal Democrat, okay? If you were to think about formulas, but if you have a table, it's easy. You can just use your good sense. So now for the other question, they want practically the same, but changing the conditioning, right? So we still are interested in those believing that the Earth is getting warmer, but we are interested in the world of conservative Republicans. Okay, so now what you need to do, you need to go to the line. Oops. So you need to go to the line of the conservative Republicans. What's the most conservative state in the US? Georgia? No. So get the most conservative state in the US. Those are the people that believes that the Earth is getting hotter. Those are the total that we have. We divided this by that. So we have 0.11 divided by 0.13. This is still 0.33. Okay, so if you were to write in formulas, I just want to point that I'm always letting clear what formulas we are watching. Oh, we are not watching, we are using. Okay. Divided by the probability of being a conservative Republican. And that's it. So the question now E asks us, does it appear that whether or not a respondent believes the Earth is warming is independent of their party and ideology? Explain your reasoning. So, the question, I will rephrase the question. So, our opinion on global warming and political ideology independent. So our opinion on global warming and political ideology independent based on letters C and D. Dependent. Yes, they are dependent because, so when you see here, we have the fact that the Earth is getting warming, okay, is getting warmer. And here we have the political ideology. When I conditioning on the fact that a person was conservative Republican, he got 0.33. Okay. So here we have the same opinion in terms of beliefs that the Earth is getting warmer. But here I changed the political affiliation to the other spectrum, to the very opposite spectrum, the liberal Democrats. And what happens was that the probability changed. So every time that you condition the same event in different events and the probability changes, it means that the events are dependent, okay? So, no, they are not independent. They are dependent because the probabilities of believing on global warming changes depending on the political affiliation. Okay, so no, they are not independent. They are dependent because the probabilities of believing on global warming changes depending change, right? Because I use change depending on the political affiliation. Is it clear? I believe it's clear. No one is writing. So yeah, pretty much clear. So now for our last question for this exercise. What is the probability that a randomly chosen respondent is a moderate liberal Republican, given that he does not believe that the Earth is warming? So for this one, what is happening here, we just changing from constraint to columns to constraint to constraint to rows to constraint to columns, right? So what is the probability that a randomly chosen respondent is a moderate liberal Republican, given that he does not believe that the Earth is warming? So does not believe. So does not believe. So this is the column of the does not believe, right? So if it is the column of does not believe, we want the row of moderate liberals. So moderate liberals, no, moderate Republicans. This is one. So meaning that we want to divide this by this. So this is probability of being a moderate Republican given that the person does not believe in global warming. So this is 0.06 divided by 0.34, and this is 0.18. Okay? Should you also include doesn't know? No, because these guys here, they refuse to respond, okay? And these guys here, they believe that global warming is a hoax, right? It's not a thing. So they are against this understanding. Did you get the point? Good. Good. We finished one more. So let's do, let me choose a very tough one. Yeah, not that tough. Let's get to number 3.19. So let's construct some probability trees. So 2 minutes, and then we discuss it. Yeah, 3.19. 3.19. The odds have answers?
All the odds and the answers are right.
Ah, so let's do an even one. Okay. I'll change to an even one. So 3.20. I think it's yeah, 3.20. Yeah, that's a good thing. Like always do the even in class. Let me see. For which one? First. So what is the probability that a randomly select person who tests positive? 6049. 0.6049. You need to invert the probability. Okay, let's do it. So we have this genetic test, and it's used to determine if people have a predisposition for thrombosis, which is the formation of a blood clot inside a blood vessel that obstructs the flow of blood through the circulatory system. It is believed that 3% of people actually have this predisposition. So the genetic test is 99% accurate if a person actually has the predisposition, meaning that the probability of a positive test result when a person actually has the predisposition is 0.99. The test is 98% accurate if a person does not have the predisposition. Okay, so what is the probability that a randomly select person who tests positive for the predisposition by the test actually has the predisposition? So first of all, let's understand what they're asking. Okay, so what they're asking is the probability that the person has the predisposition, okay, given that test positive. Okay, so what this want is the probability of having predisposition given that the test was positive. Okay, so that's what they want to compute. So let's build the tree, right? Always to build the tree, you need to identify the variables that are involved. Okay, so in this case, we have two variables. We have a variable one. There is the fact of the person is. So that's one variable. Does the person have predisposition? What are the possible answers? Yes and no, right? What is the second variable? What is the second variable?
Yes.
result of the test.
The result of the test. And test result as positive or negative. So we need these two information. So now we are going to create our tree, right? So we have a yes, and we have a no. And here we have the first variable, right? So the this position. So we have a yes with 0.03 probability, right? So 3% of the people in the world have this, meaning that 0.97 are not predisposed, I think. So now for yes, the person does the test, right? And the person can get a positive or a negative. So, and this variable here is the result. Okay? So the probability of getting a positive test if the person has predisposition is 0.99. So this is in the statement. Right? So this is 0.99. Meaning that the probability of getting a negative result if the person has predisposition is the complement. So meaning that this is 0.01. Okay? And the same thing here for those majority of us that are not predisposed. Okay? So in the exercise, they tell that the test result for those that are not predisposed are 98% accurate, meaning that 98% of the people are going to test negative, right? Because it's the accuracy. So they are correctly identified people negative, and they are, and here is 0.02. Okay, so remember the accuracy, when they talk about accuracy, it might means different things depending on the result of the test, right? Now, what do you have here in this column when you multiply is the intersection. So this is like the predisposition, right? And result. So that's this column. So this is 0.03 times 0.99. So this is 0.03 times 0.01. This is 0.97 times 0.02. And this is 0.97 times 0.98. Okay, so here we have probability of being predisposed and testing positive. So this is 0.0297. So in this line here, we have the probability of being predisposed to have thrombosis and testing negative. So this is 0.000. Ah, okay, sorry. Yeah. In this line, we have probability of not being predisposed and getting a positive result. So this is 0.0194. And so on. So this is 0.9506. So finally, the tree is ready. Now with this tree ready, we can answer the question that was asked. Yeah, so this thing that we want to compute, it's the probability of being predisposed, right? Given that the person tested positive. So by the formula, this is the probability. This is the probability of predisposed and testing positive divided by the probability of being positive, right? As I told you, the last column of our tree is the end, right? So this is like the column of the intersections. So since we want predisposed and test positive, we want this, right? So this is being predisposed and testing positive. So this is 0.0297. Now, probability of being positive, we go back to the tree, is this path here. So is, is this, right? So this is probability of being positive. Is this plus this, right? So is this plus this. This is the two possibilities of getting a positive test. So meaning that 0.0297 plus the 0.0194. And when you do this computation, it gives you 0.649. Okay? So this is the Bayes theorem. We just didn't use the formula. We just used the tree. Is that clear? It seems that everybody's going to ace in the exam.
Can you show me again how you got the bottom part?
Yeah, the bottom part is the probability of getting a positive, right? How can you get a positive? So you get a positive if you had the predisposition and the result happens to be positive. And also you get a positive if you don't know the predisposition and your test comes positive, right? So this is a false positive because you don't have the condition. So what you need to do, you need to find the lines in the tree with the positives, and you need to add the end, right? So here you have yes and positive. So meaning that this is one possibility of getting a positive result. And this is the other possibility of getting a positive result. So we need to add this, and this.
I got it.
Got it? Good. So let's do another one. Let me check. Let me get a complicated one.
Take number 6 off the exam.
Number 6 of the exam.
Take number 6 off the exam.
Okay.
We just finished the first chapter. We should put something into the-
Okay, let's do 3.42.
3.42.
Yeah.
Research.
Yeah, it's in the beginning of the chapter exercises for chapter 3.
Twins.
Yeah, twins. So 3.42. Yes. Yes.
So, that means
So is it true that that group Blink 142? You know that band? Very old band, punk rock, something like that. It's the yeah,
Is it 142 or is it
182, 182, Blink 182.
Yeah.
Yeah, it seems that it's the number of times that Al Pacino said fuck in the Scarface movie. Yeah, because yeah, it's insane. That movie is just he just keep like getting words and put the word in the middle of the words, like buy fucking Oculus. Like, what the hell?
If you want to see someone get creative with that word, on Netflix, watch Trailer Park Boys.
Which one?
Trailer Park Boys.
Trailer Park Boys.
Yeah. It's white trash.
Ah, okay,
It's Canadian comedy.
right.
Got a very big cult following. But Ricky's a character in there that I think he finally got his grade 5. But he just makes up words.
Mm.
But if you want a song that uses that word, insane clown posse F the world. I think one of his lines is in this song, I say about 96 times or 93 times.
My God, yeah. Yeah, that's good for to train the ear. It's like because I'm not a native, right?
I don't know if that's good to train the ear to those words.
Well, yeah, at least you can spot them easily.
Go to a bar with me for an hour and I'll
Yeah.
beat that.
So today something crazy happened. I was working my house in the morning, and then my wife called me, and because it was super cold inside the house and it was sunny outside, I decided to go and walk on the street. And then I was talking to my wife, video call, and then a woman was just walking with a dog. And when she was just passing in front of me in the sidewalk, I just comment with my wife, "Oh, nice dog." But I commented in Portuguese. I said to my wife, "Oh, cachorro bonito, né? Oh, nice dog." And happened that the lady was Brazilian as well.
Oh,
And then she looked at me, "Oh, you speak Portuguese in Portuguese, right?" Like, oh my God. I thought, imagine if I had said something bad, right? So I just got super surprised. Okay, so now we have about 30% of human twins are identical and the rest are fraternal. Okay, so identical twins are necessarily the same sex. Half are males and the other half are females. 1/4 of fraternal twins are both male, 1/4 both female, and 1/2 are mixed, one male, one female. You have just become a parent of twins and are told they are both girls. Given this information, what is the probability that they are identical? So, first thing, let's identify our variables, right? So, what are the type of variables that we have here? So, what is the variable 1? Type of twins. So, type of twins. Type of twins is one of the variables. The second variable? Yeah. So the sex is gender, okay? Male, female. Now, for types of twin, we have 2 possibilities. It's either identical or fraternal. But the gender, we have 3 possibilities, right? We have twins that are all males, twins that are all females, and we can have a fraternal group of twins where we have a male and a female. So we have 3 possibilities, right? So now we built our tree. So we start with the first variable, that is the type of twin. We can have identical, and identical has a probability of 0.3. And we can have the fraternal type, and this can be 0.7. This the chance that it happens is like 0.7. Okay. So it was given in the exercise, right? This 0.3%. So the identical, we have two possibilities, right? We have males. So we have two identical males. We have two identical females. And we have, well, male and female. But this is 0, right? So this one here has a probability of 50%. This was told us in the exercise. So now the fraternals, we have the same thing. We have only males, only females, and we have males and females. So, and again, the statement told us everything that we need to know. We have 1/4 here, we have 1/4 here, and we have 50% here, right? So now what we need to do, we are interested, let's just remember what we want. So you have just become a parent of twins and are told they are both girls, okay? Both girls. So we know that they are girls. So the thing that we know is the thing on what we are conditioning, right? So given this information, what is the probability that they are identical? So what we want is probability of identical given females. Okay, so we know that they are both girls. What we know is on what we condition. Okay, so and what is this? So this is the probability of getting identical and being females divided by the probability of females. Okay, so given this formula, okay, given this formula, we know which lines in the tree we want, right? So remember that I told you that this column that we are going to create here is the column of the end, right? So this is identical and male, right? We don't need this line. This is the column of identical and female. Oh, we want this line. Okay, so this is a line that we want. So this is 0.15. Okay, and we also want the other possibility of having female. So we also want this line here. So we want 0.7 times 0.25. So this is 0.175. Okay, so what is this probability here? So this probability is identical and female, and it's here, identical and female. And probability of females is this one plus this one, right? So this is 0.15 plus 0.75. So when you do this math, it gives you. So given that he knows that both are female, the chance of being identical is 46%. Okay.
That's in the calculation.
Okay. Good. Questions for this one? Yeah.
If I did not get that first thing,
Okay. So do we have questions? We are going to have a question like this one in the exam. So now is the time for asking questions, not later.
How many questions are we gonna have on the exam?
22. I'm just joking. It's only 11.
Okay, nice.
Once or multiple choice?
3 multiple choices, 1 true or false. You need to justify the falses, okay? Don't forget to justify the falses. You have questions that you need to answer things like, I'm going to give a situation and I'm going to ask you if that's what are the variables involved, what types of variable, what type of study is that, if it's like observational or experimental, those type of things. You need to compute probabilities, especially using contingency tables. You need to do like the Bayes theorem, something like this one that we are doing here, right? You need to interpret graphics like box plots, histograms. Yeah, those are the ones that I remember.
In the formulas that you're gonna provide for us, or what?
Yeah, the formulas have everything that you need. You need to know how to compute like mean, median, standard deviation, variance.
You giving us a standard deviation formula?
Yeah.
Okay.
Yeah. All the formulas that you need are in the exam. Any other questions? Any other exercise in the homework that you're struggling? There is a very nice exercise in the homework about the price of the bags when you check in luggages in the, that one is a good one. Not that it's going to be in the homework, but it's a good one for you to reasoning. How to compute variance, how to compute standard deviation. Yeah, that's a good one. Let me, what time is it now?
It's fast time.
It's past time. Okay, yeah. So we have lab. Does anyone read did anyone read the article about Taylor Swift effect and NFL? Yeah, I have one student that read. Yeah, I would just,
Between both your classes, you gotta have a student.
yeah, I have half a student. Yeah, on average, I have half a student. Oh my God. I'm going to upload the solutions so those that are interested, they can they can they can read if they are interested.
Enjoy it.
So today we don't have lab. I already covered more exercise on your class than in the other class. If you have any question, if you are struggling, with the labs, just send me a message. I'll be in my office. I can help you over Zoom, okay? But that's it for today. If you just want to go and study or go to sleep or go party, you are all dismissed.
Stratifying versus cluster.
Stratify versus cluster.
Professor, will you upload, record lecture?
I uploaded all the lectures so far. I will upload this one as soon as we finish, okay?
Thank you so much, Professor.
Okay.
First one, so.
Yeah. So for those that are still here, do you have any questions? So if not, I'm heading home. So my office hours is going to be from my home. So you can just, if I'm not still in the Zoom room, you just send me an email and I'll be there shortly. Okay?